I'm going to do some supply and demand analysis for water, water subsidies, and water price controls. This is also going to use a few graphs. Let's start by drawing a supply and demand graph for water. On the vertical axis we have P, which means price, and on the horizontal axis we have Q, which means quantity. There's a supply curve which slopes upwards. That means that at higher prices people are more willing to sell water. There's a demand curve which slopes downwards, and that means at higher prices people don't buy as much water. We have a point of market clearing, which you can see here. It means in this equilibrium there's a market price given on the vertical axis, and there's a quantity bought and sold given on the horizontal axis. In a very basic setting, there are some efficiency properties to this market price and market quantity. For instance, assume that the production of water were to be extended to the right along this diagram past the point of market equilibrium. So rather than producing water here, we would be producing water, say, somewhere out here. What would then be the case? If you look at the point on the demand curve, that tells you how much is the value of water to the demanders. If you look at the point on the supply curve, that tells you how much it's costing to supply that water. And to be producing water out here to the right, it would imply that it's costing more to supply that water than people value that water, and that would be inefficient. It means we're using too much water and we're using up water too rapidly. We would rather be back here at the point of market clearing. Now enter the water subsidy. A lot of governments make it artificially cheap for individuals in that country to use water. The water subsidy may apply directly to water, but sometimes the water subsidy is indirect and it takes the form of a subsidy to agriculture. In a typical country, agriculture will consume 60 to 80% of the water needs. So if agriculture is being subsidized, that means that indirectly water is being subsidized too. For the water subsidy, let's go back to our supply and demand curves. Price on the vertical axis, quantity on the horizontal. The supply curve slopes up. The demand curve slopes down. How we graph this depends on the exact form the subsidy takes, but one simple way to think about it is to imagine that the subsidy shifts the demand curve out and to the right. That means that at any given market price, people wish to buy more water because their purchase is being subsidized by the government. We move from a state of affairs where people were buying this much water to a state of affairs where they're now buying this much water. But they're actually buying too much water, and we can represent that quantity difference below. The demand curve, which is further out to the right, it does represent higher demand for water, but it doesn't represent higher social value for that water. The demand is higher only because people are getting the subsidy, and that subsidy, of course, is taken away from others somewhere along the line. So the real social value of water is given by this initial demand curve. The social cost of the subsidy is given by this triangle here, and economists call that deadweight loss. It represents the fact that after the subsidy, people are buying the water with an artificially inflated demand curve, which is not reflecting true social values. If you think of all of these points here, what we're seeing is that the social cost of those additional units of water is higher than the actual social value. So again, too much water is being put on the marketplace, and water resources are being used up too rapidly. The subsidy makes the private value of buying the water higher than the social value of supplying the water. In the developing world, often water use is not metered. This means that at the margin, you can use more water and you don't have to pay for it. In terms of the demand, this will make the demand very high. But in terms of willingness to supply, well, the businesses who supply water, since they can't charge more for supplying extra, they're not so keen to supply more. This will bring about a problem. Let's go back to our supply and demand graph. Again, we have price on the vertical axis, quantity on the horizontal axis, a downward sloping demand curve, an upward sloping supply curve. And now, if there are no meters, in essence, at the margin, what's the price of water? It's going to be 0. Supply will be here. Demand will be here. There's a big gap between how much people want to buy of water and how much water will be supplied, and that is the size of a water shortage. And that all comes about because at the margin, water is not being priced, because in this case, there are no water meters. There are other forms of water price controls. Imagine, for instance, there's simply a law saying that water cannot be sold For any more than this price, we can then draw across the quantity of water supplied is this amount, the quantity of water demanded is this amount, and again we have a shortage of water given by the difference between desired quantity demanded and the quantity of water which suppliers are willing to put on the market. There's another interesting feature of these kinds of outcomes. When the price is too low, there are more people wanting to buy water than there will be water supplied. So that water somehow has to be rationed or allocated. Often it's allocated in terms of political privilege. Who has the pull with the government to get the permits or the licenses or the access to water? In a market setting, the people who get that water are the people willing to pay the most for it, or the people who, in economic terms, value that water the most. When there's a price control, this means that who gets the water has more to do with politics, and it may or may not be the people who actually value the water most in economic terms. This is a potential inefficiency, namely that the people who are getting the water are not the people who value the water most in economic terms. This is one reason why economists typically favor tradable water rights. Let's say we're in a situation where the people who are getting the water, through whatever mechanism, are not the people who value the water most in economic terms. If those water rights are tradable, the people who get the water will trade that water and those water rights to people who value the water more. That will make the outcome, again in economic terms, more efficient. When the water rights are not tradable, we are stuck with the people owning or using the water being the people who are not those who value the water most. To sum up, these are some basic settings in which markets for water, prices for water, and the trading of water rights help bring about more efficient outcomes. This analysis does not take into account all of the complexities of water markets or all of their social ramifications, but think of it as a very basic starting point for understanding some of the things which can go wrong in regulated water markets. Subsidies can cause excess water use, and price controls can cause inadequate water supply.